So we're looking at multiplying and dividing rational expressions. So first, before you multiply and divide, I'm going to see if you can simplify. So simplify, you look at the top and the bottom to see if they have any common factors. So if it looks like this, you're going to need to factor it first. So 8 and 2 have a 2 in common. X cubed and x squared have an x squared in common. And then I need to write what's left. 8 divided by 4. 8 divided by 2 is 4. And then x squared times x is x cubed. And then this whole term right here is out front. So that means that I have a 1. 2x squared times 1 gives me 2x squared. And I was subtracting, so I'm going to subtract here. And then on bottom, my denominator, I have an x in common. And if you notice, there's a 4x minus 1 and a 4x minus 1 in common. And there's an x in common. So that leaves me 2x. So we're not always going to be this fortunate that the numerator or the denominator just cancels, just goes away, and we don't have a fraction anymore. We just have 2x. There's just a single term. And then number 2, we have 4 terms, and so I'm going to use the box. So 2x cubed minus 6x squared, 7x minus 21. So 21 and 7 have a 7 in common. 7 times 1 gives me 7. These have an x in common. X times 2x squared gives me 2x cubed. And 7 times negative 3 gives me negative 21. So my numerator is 2x squared plus 7. X minus 3. And then on the bottom, I have the difference of squares. Where I see 9 is a perfect square, and x squared is a perfect square. Meaning that I can square a whole number and get 9. And x times x gives me x squared. To get the negative, I'm going to add and subtract. And so I have an x minus 3, that's common, top and bottom. So that leaves me 2x plus 7, or 2x squared plus 7 over x plus 3. So for 1 and 2, I needed to factor. And find what was common. And I'm going to rewrite a clean fraction. So this is all cleaned up. And here, when I'm multiplying, it's almost the same as if I'm simplifying. But I have 2 fractions. And so I have more things to factor. That I have a 4x from each term. So I need an x plus 1. And over here I have an x in common. Gives me x plus 1. And so now I just need to factor 2x squared minus x minus 3. So I use my x. I'm going to multiply my first and my last terms together. I get negative 6. And then my middle term. So I need two numbers that multiply to negative 6 but add to be negative 3. So I need negative 3 and 2. So 2x times x to give me my 2x squared. 3 has to go somewhere where I'm not multiplying the 3 and the 2 together. My last two numbers have to multiply to give me negative 3. So negative 3 times a 1. When I FOIL this out, that's going to give me 2x squared minus 3x plus 2. So these, the inner and the outer of my FOIL come from the x, these two numbers, negative 3 and 2. When I'm multiplying the outer and the inner, I need to get these two numbers. So that's what I was kind of saying. I have to multiply, I gotta put negative 3 somewhere so that I'm not multiplying it by 2. Because I needed a negative 3, so negative 3 times x would give me a negative 3. And 2 times 1 would give me a 2. So these are my two factors. 2x minus 3, x plus 1. So 2x minus 3, and then only one of my x plus 1s. I'm going to have one left over, and x is gone. So I have 4 x plus 1. And then this one, 4x is common. And then down here, x times x gives me x squared. And I have a 3 and a 1 to multiply to give me my negative 3. So I gotta figure out which one of these is positive, which one is negative. So to multiply, to add to get a negative, to add to get a positive 2, it has to be plus 3 minus 1. And then over here, 4x doesn't go anywhere. Here, x times x gives me x squared. And then I need two numbers that are 1 apart, so 3 and 2, to multiply to give me a 6, and somehow add to be plus 1. So positive 3, negative 2. So 4x is gone, x plus 1, or x plus 3, and x minus 1. So I'm left with x minus 2. So now I'm dividing. So some of you have heard keep, change, flip in middle school. So you're going to keep the first fraction, change division to multiplication, and you're going to flip the second fraction. So here, to make x plus 1 into a fraction, I'm going to write it over 1. So it magically becomes a fraction. And so when I rewrite this, I'm going to keep the first one. Change. And flip. So I still need a factor. So I know that for anything to cancel, I'm either going to factor and have an x plus 3, or I'm going to factor and have an x plus 2. So 4 would have to be 1 and 4, that would give me 5, so it has to be 2 and 2. So x times x is x squared, 2x plus 2x gives me 4x, and 2 times 2 gives me 4. And so x plus 2 cancels and leaves me x plus 2, x plus 3. So sometimes we are going to have a fraction as an answer. Sometimes we won't. Sometimes we might get something awful and it equals just a number. So I want to always start off by doing the keep change flip. And then factor. Otherwise, like, I could have a lot of factors running around, like on number 7, and then I flip the wrong fraction or something, so I'd rather just keep the original and do the keep change flip before I factor. There's many ways to mess these problems up. I don't know where to start. Well, here is a 2 in common. Then over here is a 2 in common. This is going to multiply to be negative 6. That to be negative 1, so that's negative 3 and 2 again. Negative 12, positive 1, negative 4 and 3. That one we did on another problem. Negative 3, x plus 2. Oh, x plus 1, I'm sorry. So this one, 2x and x. 3 is going to go where I'm not going to multiply by it. But to get a negative 4, that's in my outer. 2 times negative 2, and my inner is 3. So just like here, my inner was negative 3, and my outer was 2. Oh, it's positive 4, negative 3. For it to add, to be a positive, a bigger number has to be positive. Okay, that's where I messed up. Oops. Changed the wrong one. So I have 2x minus 3 in common. There's a 2 in common. So I'm going to have to factor this. That is my difference of squares. 4 is a square, and 16 is a perfect square. My first fraction, I'm left with x plus 1, x squared plus 4. X minus 2. I'm running out of room, so I'm going to add a sticky. So x to the 4th minus 16, that's going to be x squared and x squared. For the difference of squares, I need something squared. So it's a term multiplied by itself. 4 and 4, plus and minus. And if you notice, I have a minus, and these are squares. So x plus 2, x minus 2. And x minus 2, x plus 4, x squared plus 4. And so for this one, I'm left with x plus 1, x plus 2. And this one looks like a previous problem, but you're also multiplying. So you're dividing and multiplying in the same. So the keep, change, flip. So the keep, change, flip only applies to these two. I'm not going to flip this one. So the third fraction stays the same. And so for the first one, so multiply to 6, but add to 5. So 3 and 2. And the second one multiplies to 12, but adds to 7. So that's 3 and 4.